Hello and welcome to Dr. Anima Upadhyay's Chemistry and Technology and Chemistry lecture videos. Today's topic is chalcogens. Chalcogens belongs to oxygen family of group 16 in the periodic table. Chalcogens are very important from the point of view of research and technology. So, it is equally important for scientists as well as for technologists. If you have not subscribed to my channel so far, please do it. And also share this video among your friends who want to learn about chalcogens. In this video, instead of writing big paragraphs, I have formatted in the form of questions and answers so that whatever questions arises in your mind are answered here, and it will be a better understanding for all those who want to know and learn about chalcogens. So whenever we talk about something new, the very first question comes to our mind is, what is the origin of this word? So what is the origin of word chalcogen? Chalcogen is derived from the combination of two words. One is Greek and the other is Latinized Greek word. So the Greek word chalcos, which means copper, and is used to name ore or a coin, and the Latinized Greek word is genes, which means born or produced. So this was because most of the copper ores have small amounts of selenium and tellurium. So in short, we can say that chalcogens are ore forming elements. What are chalcogens? Chalcogens are ore forming chemical elements, as I have already explained to you, and it belongs to group 16 of the periodic table. This group is also known as oxygen family. The elements which are present in the group are oxygen, sulfur, selenium, tellurium and polonium, which is radioactive. A chemically uncharacterized synthetic element, livermorium, is also included in chalcogen, and this element was discovered in the year 2000. In what state of matter does chalcogen exist? Except for oxygen, which is a gas, all chalcogens exist in the solid state. Is oxygen included in chalcogens? If not, why? Oxygen is treated separately from the chalcogens and sometimes even excluded from it. The reason is simple, that it has a different chemical behavior from sulfur, selenium, tellurium and polonium, and this is the reason it is separated from the chalcogens. What is the electronic configuration of chalcogens? It is represented as Ns2Np4. How many electrons are there in the valence shell of the chalcogens? All chalcogens have 6 valence electrons in the valence shell, making them 2 electrons short from the octet. What are the common oxidation states of chalcogens? The common oxidation states for chalcogens are -2, +2, +4 and +6. When and how livermorium was discovered? In the year 2000, livermorium was discovered when scientists at Dubna, Russia bombarded a curium-248 target with accelerated calcium-48 ions. What does livermorium means? Livermorium means a short-lived element as it decays within milliseconds. What is the atomic mass of livermorium? The atomic mass of livermorium is 116, 116, and it is the heaviest element among the chalcogens. What are the commercial uses of livermorium? It has no commercial uses except in atomic research on super heavy atoms, as it decays very fast and only a few atoms of it has been produced so far. Do all chalcogens have allotropes? Yes, almost all chalcogens have allotropes. What are allotropes? Can you give some examples using carbon and oxygen allotropes? Allotropes are different forms of the same element where the atoms combine in different ways so that they can exist in different forms at same temperature and pressure. Allotropes of carbon are well known, diamond and graphite. And allotropes of oxygen are also well known, the diatomic oxygen and ozone, O2 and O3. What are some commonly known allotropes of sulfur and selenium, and also state their stability? Sulfur has two allotropes, rhombic sulfur and monoclinic sulfur. Between these, rhombic sulfur is more stable. Selenium has three allotropes, red, grey and black selenium. Red selenium is most stable and on heating it becomes black selenium. Give the allotropes of tellurium and polonium. Tellurium and polonium both have two allotropes each. Allotropes of tellurium are crystalline and amorphous, and allotropes of polonium are alpha and beta, which are both metallic. Is selenium a metal or a non-metal? Selenium is a non-metal. In chemical activity and physical properties, it resembles sulfur and tellurium. Is tellurium a metal or a non-metal? Tellurium is a metalloid. It shows the properties of both metals as well as non-metals. Thus, we can say it as a semi-metal. Is polonium a metal? Polonium is a radioactive metal and is the most lethal material too. What are the general properties of chalcogens? All chalcogens are reactive to alkali earth metals. All chalcogens found in metallic ores are in the form of ions. Lighter chalcogens such as sulfur and oxygen are non-toxic and essential to all life forms on the earth. Heavier chalcogens like tellurium, selenium and polonium, on the other hand, are toxic and harmful. Chalcogens have various atomic sizes. However, all of them have 6 valence electrons. Density, melting point and boiling points, as well as increases with the atomic weights, as well as the atomic radius. Density, melting point, boiling point and the atomic radius, all of them increases with the atomic weights. Oxygen, sulfur and selenium are non-metals, while tellurium and polonium are semi-metals and conduct electricity. Usually, the oxidation number of these elements in a chalcogenide is -2. However, in ores such as pyrite, oxidation values may change. Which chalcogens are photoconductive and which is a radioactive element? Selenium and tellurium, Se and Te, are photoconductive and polonium, that is PO, is radioactive. Polonium is formed by the radioactive decay of uranium and thorium, U and TH. Does chalcogens react with halogens? Yes, they react with halogens to form chalcohalides or chalcogen halides. Does chalcogens react with organic compounds? Yes, they react with alcohol, phenol and other similar compounds having oxygen and replace it by sulfur, selenium and tellurium. S, Se and T forming chalcogen compounds. Example, thiol, thioether, siloether, thioketones, seleno and telluroketones. They show non-linear electric and photophysical properties and therefore they are very important. Does chalcogens react with metals? Chalcogen reacts with metals also such as alkali metals, transition metals except for copper and zinc, boron group metals and form metal chalcogenides. What are the other elements with which chalcogens react? They react forming single and double bonds with silicon, germanium and tin. They also react with hydrogen to form hydrides and with boron to give borides. Why study of chalcogens has become so important? Chalcogens have 6 valence electrons, thus making them chemically unstable. In order to attain stability, they have to react and fill their outer electron shell by forming covalent bonds with nonmetals and ionic bonds with metals. Hence, they are capable of making new materials, expanding the new area of interests in the various fields of research, thus making it multidimensional. What are chalcogenides? Compounds of chalcogens are called chalcogenides. That is a compound consisting of at least one chalcogen ion and at least one or more electropositive element. What are some important properties of chalcogenides? Chalcogenides materials mostly exhibit semiconductive properties and are suitable for solar cells, optoelectronics, sensors, thermoelectric, especially as multinary chalcogenide materials. What are multinary chalcogenide materials? State their applications. Multinary chalcogenide semiconductor nanocrystals are a unique class of materials. They offer flexibility in composition, structure and morphology for controlled band gap and optical properties. They offer a vast selection of materials for energy conversion, storage and harvesting applications. They are versatile materials for a variety of optoelectronic and energy conversion applications, including single and multi-junction photovoltaic, photoelectrochemical water splitting, thermoelectric and non-linear optical crystals. The thermal transport and thermal management properties exhibit an extraordinary role for long-term reliability of devices, performance and energy use. The dimensional crossover from 1D to 3D of chalcogenides gives opportunity to study fundamental physical questions of thermal conduction. A knowledge of thermal transport in chalcogenides would be beneficial for thermal management of next generation electronic related devices and efficiently controlling thermal energy transport and conversion. What are the recent advancements of chalcogenide materials? The recent advancements in chalcogenide materials are that the chalcogenide inorganic or organic polymers synthesized from elemental sulfur with the incorporation of inorganic chalcogenide components, that is sulfur, selenium, tellurium in the organic polymeric backbones. Chalcogenide glasses have recently gained attraction because of its innumerable applications. The current interest in the chalcogenide materials are as glasses centers on X-ray imaging, photonics, optical sensors, optical filters, electric switches. Amorphous semiconducting glasses exhibit a unique property of reversible transformation. This makes these glasses very useful in optical memory devices. Indium monoselenium glass has an energy band gap about 1.3 electron volts. This is close to the theoretical optimum value for solar energy conversion. Thus, these glasses have great potential for solar energy conversion, especially in the form of amorphous or polycrystalline state. Chalcogenide nanocomposites are effective fiber lasers produced by doping transition metals with zinc, selenium or zinc sulfide powders in chalcogenide glasses. I have only talked about the chalcogens, their physical and chemical nature, and the importance of chalcogenides in modern research and technology. To learn more about the chalcogenide composites and chalcogenide glasses, keep watching. Don't forget to like this video and share it among your friends. Subscribe to my channel Dr. Anima Upadhyay. Thanks and take care.